these two reagents. This is aqueous sodium hydroxide and this is liquid ammonia or ammonium hydroxide. And here we have different samples. Sample A, you can see it is transparent. Sample B is also transparent. Sample C is also transparent. Sample D is colored. This compound is that is brown and it is slightly light brown color. And we have solution E, which is blue in color, and here solution F. I will repeat the solution F because it is unstable. Please give a balance of it. Distort. Thank you. And this is solution F, that is light green color, and this is solution G, which is dark green in color. And then we will discuss the solution H and solution I later on. But right now, you should observe that we have two other test tubes with the same level. 2 for A, 2 for B, 2 for C, 2 for D, 2 for E, 2 for F, 2 for G and 2 for H. I will show these later on because up to this we have only these 1, 2, 3, 4 and 5 ions. Okay. Now we start with it. I don't know whether it is zinc, aluminum or calcium, but we can rule out the presence of copper 2 ion and iron 3 ion, because we know copper 2 ion, solution of copper 2 ion is generally blue in color and solution of iron 3 ion is reddish brown in color. So most probably it would be iron 3 ion solution and it would be copper 2 ion solution. So we will see it later on. First we will observe these colorless solutions. So we have two test tubes marked with the same letter A. So first I am adding a small quantity, about 1 to 2 ml is enough. And first of all, you can observe I am adding a very small quantity, very small quantity of sodium hydroxide. You can observe there are white precipitates. So sodium hydroxide gives white precipitate with a small quantity of sodium hydroxide. Now I am adding more sodium hydroxide. In this large quantity, you can observe where are the precipitates? There is no precipitate. What does it mean? It means precipitate have been dissolved. So what should be the line? It is white precipitate, precipitate dissolves. It is white precipitate, precipitate dissolves. The next is white precipitate form, it remains. So we can rule out the presence of calcium here because precipitates are soluble in excess of sodium hydroxide. But we are still confused between zinc and the aluminum ion. So we can perform another test with ammonium hydroxide. Here Again we have taken a small quantity, 1 to 2 ml. Now we are adding a small quantity of ammonia as prescribed in this scheme, and see the result. If you observe, it gives white precipitates. Now, white precipitate is both the zinc and aluminum. So, we are still confused. So, we have another test in this scheme. Then we can access the ammonia solution here and observe whether the precipitates are soluble or insoluble. You can observe that even in the excess of ammonium hydroxide, precipitates remain insoluble. It means we can rule out the presence of zinc, but it must be aluminum. So, what is a solution? It means solution A contains aluminum ion. I can write it here so that you can remember it. Now, another solution is B. Again, we have to check whether it contains aluminum ion, zinc ion, or calcium. These are the unknown samples. You don't think that aluminum may not be present, because aluminum, we have found aluminum in A. You should know, if you have an unknown sample, then you can consider all these three ions. So, first we will check again with sodium hydroxide, a small quantity of sodium hydroxide. You can see it. Oh, white precipitate. You can observe it. Now, again, we are still confused whether it is zinc, aluminum, or calcium. Now, we can add the excess of sodium hydroxide. Oh, it is almost soluble. Okay, it is soluble. If we will dissolve it, so it is soluble in excess of sodium hydroxide. Now, we are going to test with liquid ammonia. Not liquid ammonia, liquid ammonia, I am sorry. With a small quantity of ammonia, it is white precipitate. You can observe these white precipitates. But in excess, these white precipitates must be soluble. But I think the quantity of hydroxide is more than quantity of zinc ion is more than the required. So I can check it after throwing half of the solution. You can do it. Yes, you can see it is soluble in ammonium hydroxide. So which one is soluble? If it dissolves, then it would be zinc. So now you can see, first we have tested this sodium hydroxide, the small quantity of precipitate, and in excess these are soluble. Now, in a small quantity of ammonium hydroxide, it is white precipitate, and in excess these precipitates are dissolved. So it means the solution B contains zinc. Now come to solution C. Again, I am performing the same test. Solution C is taken in a small quantity in a test tube. Then we will add a small quantity of sodium hydroxide. See, again the white precipitates form, and instead of dissolving this precipitate remains soluble, even the precipitate increases. So it might be calcium. Now we'll see the same result, will perform the same test with ammonium hydroxide. First we will add a small quantity of ammonia. It is giving white precipitate as it is initially. I think I should perform this test again because of I think solution is more concentrated, so I should dilute it. So you can see here the small quantity of solution C, and we will add a small quantity of ammonia first. No precipitate, but in an axis it may give slight precipitate. Yes, it is giving slight precipitate here. Remember that sometimes if someone in axis, either the calcium ion or the ammonia solution, then it may give slight white PPT. But you can see the difference in these two PPT. These are very clear PPT. Axis of PPT are there, but in this case, PPT are slight. So you can see this difference. So means these are calcium ions in this solution C. Now, in solution D is light brown in color, and sometimes some author write it as yellow solution. The yellow solution showing that it might be iron 3 ion, and if you have a colored solution, then you should think about the transition element. It means the ions are from transition element, transition metal. You know, iron is one of the transition metal, copper is another transition metal, so it might be copper. So in colored ions, it is easy to identify just by observing the color, but in chemistry we must check it by some chemical test. So we perform the same test. First, we are taking the small quantity of the solution D and we are adding sodium hydroxide. Oh, you can see reddish brown precipitates are formed. Now we can add more sodium hydroxide, and even in more sodium hydroxide, in the excess of sodium hydroxide, these precipitates are insoluble, and result is, as per our thinking, our guess, that red brown colored form and PPT remained insoluble, so it might be iron 3 ion. Now we will check the same solution with ammonia. See here. Again, precipitates are formed, and even in axis, precipitate increases instead of dissolving. So we can say that these PPT are insoluble. So see what we have written. Yes, red brown PPT form and PPT remain insoluble. So it means the sample D contains iron 3 ion. Now come to solution E. In solution E, again the test is similar. Only 2 reagents are enough to distinguish these ions. Oh, light blue color is obtained. So this light blue precipitates shows the presence of copper ions. Pale blue, light blue precipitate. Pale blue or light blue are similar thing. PP do not dissolve. So first, yes, PP remain insoluble. You can observe this. Now we perform another test of the same solution E with liquid ammonia or ammonium hydroxide. Again, we obtain white precipitate. Blue precipitate, light blue precipitate. But in excess, it is becoming darker and darker. See here, in excess, the solution becomes more darker. It means it is deep blue coloration on axis of ammonium hydroxide. And see this here, deep blue coloration. So, out of these A to F, I will explain F and G in next video, but just focus on from A to E. A, we have found A is aluminium, B is zinc, C is calcium, D is containing iron, 3 ions, so we should write here D, and E is containing copper 2 ions. So students, now you can observe that how can we distinguish these ions and how can we detect these ions. So in the laboratory, it is an easy method. Just by using these two solutions, you can detect these ions, you can distinguish these ions. Okay? So, inshallah, the other ions I will discuss in the next video.